Artemis III approaches the far side of the moon, and then it happens. One by one, the streams feeding mission control begin to disappear. Telemetry drops away. Voice contact goes silent. The steady flow of information from the spacecraft simply stops. On the ground, flight controllers watch data indicators vanish from their screens as Artemis slips behind the lunar horizon. The spacecraft keeps moving. The crew keeps working. But from Earth, it is suddenly impossible to see any of it. At first, signal loss sounds like a malfunction, a broken antenna, a failed system, an unexpected problem. But this blackout is different. It is guaranteed. The moon itself blocks direct radio communication between Artemis and Earth. As the spacecraft passes behind the lunar far side on its planned lunar orbit trajectory, the connection is physically cut off. The same thing happened during every Apollo mission. The result is immediate and unsettling. Controllers cannot check the crew's status. They cannot monitor the spacecraft's condition. They cannot watch events unfold in real time. For a brief stretch, everyone on Earth is reduced to waiting while Artemis continues alone on the far side of the moon. And that raises a much bigger question. If this blackout is expected, why does NASA still treat it as such a serious moment? Artemis III is now behind the lunar far side, still following its planned path, still carrying out its mission. Nothing has stopped on board. The only thing that has stopped is Earth's ability to participate. Inside Mission Control, the screens that once showed a constant stream of spacecraft data are gone. Flight controllers are no longer tracking live telemetry. Instead, they are watching clocks. The mission timeline continues to advance, but they cannot see it happening. That changes the situation completely. A communications blackout is not just the loss of information, it is the loss of options. Any command from Earth is blocked by the moon. Any troubleshooting advice is blocked. Any request for confirmation is blocked. If the crew wants to ask a question, that conversation cannot happen. If controllers want to verify something, they cannot. Meanwhile, Artemis III keeps moving. Mile after mile, the spacecraft travels beyond direct contact, while Mission Control can only wait. With every passing minute, more mission activity unfolds outside Earth's supervision. That is why the assumption that Mission Control can always step in begins to break apart. Modern spaceflight relies heavily on continuous support from the ground. Yet during this stretch, that support effectively disappears. And if something changes while Artemis is still on the far side, nobody on Earth can respond in that moment. The longer Artemis autonomous operations continue, the less traumatic the blackout can start to feel. Inside the spacecraft, the crew is not waiting for instructions from Earth every minute. They follow procedures that were prepared long before the mission left the ground. Planned tasks continue, checklists continue, the mission timeline continues. Navigation systems keep operating normally. Artemis remains on its expected path behind the lunar far side. Even without contact, the spacecraft does exactly what it was designed to do. That is not an accident. The entire blackout window is known in advance. Crews train extensively for periods without Earth contact, and mission procedures are built around that reality. While Mission Control sits without telemetry, astronauts continue working through pre-planned activities, and controllers already know roughly where the spacecraft should be and what the crew should be doing. From the outside, it begins to look surprisingly routine. The spacecraft keeps functioning. The crew appears fully capable. The timeline stays on schedule. For a moment, a reassuring conclusion starts to form. Maybe this is simply the price of going behind the moon. Maybe communication disappears, but the mission itself remains firmly under control. And if that is true, then the blackout sounds far less threatening than it first appeared. But that reassuring picture depends on one critical assumption: that nothing changes. In Artemis mission operations, planning is built around known situations. Procedures exist because engineers can predict them. Training exists because crews can rehearse them. As long as reality follows the script, the blackout looks manageable. Then imagine something new appears. A crew member notices something unexpected. A system behaves differently than anticipated. A question emerges that was not part of the plan. The crew can see it immediately. Earth cannot. There is no communication path through the moon. No way to send the new information home. No way for specialists on the ground to examine it. No way for mission control to compare data, discuss possibilities, or help evaluate what the crew is seeing. The astronauts must continue before mission control can even hear the problem exists. That is where the comforting explanation begins to break down. If preparation completely solved the blackout, real-time support would no longer matter. But space missions still maintain mission control for a reason. Unexpected situations happen despite preparation. New information appears despite planning. The blackout does not remove Earth's expertise. That expertise is still there, waiting on the other side of the moon. What disappears is access to it. A crew can be fully trained. The spacecraft can be operating normally. Every procedure can be followed exactly as intended. Yet the moment something unforeseen appears, decision responsibility remains on board, because the most important resource on Earth becomes temporarily unreachable. That is, the safety layer isolation quietly takes away. Artemis eventually emerges from behind the moon.
The Artemis mission marks
The silence ends almost instantly. Telemetry returns. Voices return. Mission control watches its screens come back to life as the spacecraft reappears from the far side and reconnects with Earth. On the surface, it feels like the problem is over. But Artemis has not revealed a temporary weakness. It has revealed a permanent condition of lunar exploration. The lunar far-side communications shadow exists because of geometry, not technology. The moon itself blocks direct line-of-sight communication. As long as a spacecraft follows similar lunar routes, that shadow remains waiting on the far side. The result is easy to picture. Artemis passes through it. Future missions pass through it. Any spacecraft traveling through the same region encounters the same corridor, where direct communication disappears. That turns the blackout into something much larger than a single 45-minute event. It becomes a recurring operational constraint. Future crews can prepare for it. Future systems can work around it. Additional relay networks may expand coverage, but the underlying reality does not change. The moon creates a physical communications shadow that lunar infrastructure must navigate rather than eliminate. And that is the real lesson of Artemis. The challenge was never simply losing a signal. The silence was never the real risk.